Okay, and when you guys have looked at what absolute value means, people have always probably just told you whatever number's inside the absolute value sign, you just take that number and you make it become positive. That's what they typically tell you. But it's a little bit different than that. Like, yes, you do take it and you make it positive, but the definition is a little different. The definition of this literally means the distance from x to 0. That's what absolute value actually means, is you're talking about the distance from whatever is inside the absolute value sign, how far away that is from 0. And since it's a distance, that's why the number is always positive. So the way you learned it, the way people have always explained it, is correct. It's not wrong. You're right if you think like, oh, I should always make it positive. But the reason that we always make it positive is because we're always saying, oh, how far away is that from 0? It's a distance. Okay, and distances are always positive. You would never say like, oh, I am negative 5 miles from my house right now, because I went out my driveway and I went to the left, so I went negative 5 miles. You would never say that. Or like, I went south to Florida, so I went negative 500 miles. Nobody says that. They always say I'm 500 miles away. I went 500 miles. It's a positive distance. All right, so let's go ahead and do some example problems. For example 1, we're going to say if the absolute value of n is 9, what are the solutions that n could be? So if n is a number so that its distance from 0 is 9, what are the numbers that n could be? What are the numbers that are a distance of 9 away from 0? There's 2 answers. What numbers are 9 away from 0? 9, yep, so let's think of a number line. We've got 0 right in the middle. 9 is over here, so the number 9 is a distance of 9 away from 0. So n could equal positive 9. Okay, what else could it equal? Negative 9. So n could also equal negative 9. So whenever we solve absolute value equations, we always have 2 options, because we have to think about, well, what if you went out your driveway and went to the left that distance? What if you went out your driveway and went to the right that distance? You always have 2 options when you're finding distances. Does that make sense? Because you can always go 2 different directions. Okay, let's do this again. So we're going to say this time we have 2 multiplied by a number is going to give us a distance of 8. 2 multiplied by a number is going to give us a distance of 8. So I'm going to say the number that's inside here could have been a distance of positive 8, right? So we could be solving the equation 2n equals positive 8, or we could think of this like we went out of our driveway and went to the left. And we could think of this as 2n equals negative 8. We could have the negative version. So we could think of it as this way on the number line, the positive distance over here. Or again, we still have a positive distance, but we could just think of it as we went to the left instead of went to the right. So what happens if I solve this? How do I get the n alone? Divide by 2, okay? So n equals 4, okay? Over here, I'm going to divide by 2, and what do I get? Negative 4. Okay, so if my number is positive 4, 2 times positive 4 is 8, which is a distance of 8 from 0. Or I could have the number negative 4. 2 times negative 4 is negative 8. That still has a distance of 8 from 0. They both have a distance of 8. Okay, here's the next one we're going to try. We're going to make it a little bit more complicated. Now, when I do problems like this, I like to make my absolute value lines really long so that I don't think they look like ones. So 2 times the absolute value of 3 plus r equals 8. And now, since I'm getting closer to kind of like solving an actual equation, I have to think about what things can I undo to get the r value closer to being alone. And when you start to undo steps in an equation to get the variable by itself, you have to do order of operations backwards. Do you guys remember what order of operations is? People often say, please excuse my dear Aunt Sally. PEMDAS, yeah. So PEMDAS is like the way you do it forwards. PEMDAS forwards is how you add and subtract and multiply and divide numbers together. If you're solving an equation, you do it backwards. And even though, please excuse my dear Aunt Sally, it has 6 letters, it only has 4 steps. The first step to PEMDAS is the P, the parentheses. The second step is the exponents, it's the E. The third step is actually 2 letters. What's the third step? And division as the same thing, right? You can do multiplication and division as the same step together. You do all of them. And then the fourth step is the addition and subtraction. So when we are solving an equation, we do those steps, but we do them backwards because we are undoing the operations. So instead of doing them forwards, we go backwards because instead of doing something, we are undoing it. So we go backwards, okay? So we're going backwards, which means PEMDAS backwards. And so the first thing we're going to do is say, okay, is there something to get the r alone that we could add or subtract to the other side? And we cannot, because this 3 that's being added to the r is protected by the absolute value signs. It's on the inside, it's protected, so we can't do anything for step 1. Step 2, is there anything we could multiply or divide to the other side? Is there anything that's currently multiplied or divided where we could undo it? Yeah, the 2 is currently multiplied, so we're going to divide it. I'm going to divide 2 over to the other side. Okay, so that leaves me with the absolute value of 3 plus r equals 4. So this says that 3 plus r represents a number, and the distance of that number to 0 is a distance of 4. Is that reasonable? Can we have a distance of 4? Yeah, okay, so when we see that our answer is reasonable, that's when we say, okay, let's keep going, and we have 2 options. We have that our distance could have been to the left, 3 plus r could have been to the left, or 3 plus r could have been to the right. So I say 3 plus r could have been to the left, 3 plus r could have been to the right. I set it up for both situations. Okay, so what I just did is I said if I keep going through my order of operations, there was no exponent, so I basically skipped that step. And then the last step was to get inside my parentheses. And they say only parentheses when you're younger because parentheses is the only thing you really see. But what they really mean is grouping symbols. And for us in this class right now, the grouping symbols are the absolute value sign. So we're not going to see parentheses on this problem. We're going to see the absolute value symbols. So what we did is we just got inside the absolute value symbols. Now we're going back up to the beginning of the steps. So is there something we can add or subtract to get away from the r? The 3, yeah. So we'll minus the 3, minus the 3. And so r equals 1, and what else? Not negative 1. Four negatives and 3 negatives. 7. 7 negatives, yeah. Good. So 3 plus 7 negatives is -4. The absolute value of -4 is +4. 2 times 4 is a distance of 8. Makes sense? 3 plus 1 is 4. 2 times 4 is a distance of 8. So we're good. We got it. Okay, let's try another one. Okay, this one's going to have more steps. Okay, so 5 times the absolute value of 8a minus 5 minus 1 equals 104. So first step, we see, is there anything we could add or subtract to the other side? I see 2 numbers, but only one I can get to. One of them's protected. Is there anything I could add or subtract to the other side? Yeah, there's a -1, and I can move that. How do I move a -1? Add it, okay. Now, the -5 I couldn't move because it was protected. It was protected by the sign, the absolute value symbols. Okay, so I've got 5 times the absolute value of 8a minus 5 equals 105. My next step is looking to see if there's anything that is multiplied or divided that I could undo. Thanks. Is there anything multiplied or divided I can undo? Lexi, go ahead and bring your phone up here. Thanks. Anything multiplied or divided that I can undo? So I can divide by 5, divide by 5. $105 divided by 5. Anyone know? 20. 5 goes into 100. Anyone know how many fives are in 100? 20. It's 20, and then an extra, so it's 21. And for the next 2 steps, we have exponents. There's no exponents for this problem. And then the P is for our grouping symbols. So what we're going to do next is we're going to get this out of the absolute value. So we have an absolute value equals 21. So now we're going to say, okay, we've got 2 situations. We have that this distance could be a positive 21. This distance could be like a negative 21, like you went to the left. So on the number line, you went to the right 21 spaces, or on the number line, you went to the left 21 spaces, okay? So I'm going to say 8a minus 5 is negative 21. 8a minus 5 is positive 21. Those are my 2 options. But both of those are a distance of 21. It's just that one went to the left, one went to the right. They both have a distance of 21. And now I go back up to the beginning and I say, okay, let's see if there's something you could add or subtract to the other side to get the a alone. What should I do? Add the 5. So we have a negative 21 plus 5. 21 negatives and 5 positives. (21 negatives and 5 positives). 16 negatives, good. Okay, and then over here we've got 21 and 5. What does that add to? 26, good. Okay, so we did adding and subtracting. Now we're going to multiply or divide to get the a alone. What do we do? Divide by 8. Perfect. So what are the answers? -2. Okay. And then the other one is 26 divided by 8 doesn't divide evenly, so we're going to leave it as a fraction. These are both even numbers. So 26 and 8, they can reduce. So if we do the top and we divide it by 2, and we do the bottom and we divide it by 2, what would the top be? 13, and what would the bottom be? Not 3, 4, good. So 13/4 is what we'll call that one. That's a 13, the 3 looks weird. 13/4. Okay. I want to show you one more, but how are your guys' brains feeling? Going. Okay. I'm going to show you guys one that is kind of weird, and then I'm going to let you guys kind of practice one on kind of with me, kind of on your own, and then I'll give you guys your assignment. Okay. So this one is the weird one. 2 times the absolute value of 2x minus 1 equals -34. Okay, so first step, can we add or subtract anything to the other side? Is there anything we could add or subtract? No? Okay. Is there anything we can multiply or divide? I think I heard it. Can we multiply or divide something? Yeah? What can we multiply or divide? The 2. So I'll divide by 2, divide by 2, and 34 divided by 2 17. Okay. So at this point, I have this number has a distance of -17. This number has a distance of -17. Does that make sense? This number has a distance of -17. Can you have a distance of -17? No. So look at this. We're going to write this in our notes. Distance is negative. And anytime that happens, anytime you have an absolute value equals a negative number, which is not possible, that can't happen, then your answer is no solution. There's no way you could solve an absolute value problem to get a negative. That's not how they work. So these problems are annoying because you have to remember that, but they're kind of nice because you start the problem and then you don't have to finish it. So it's kind of it's like a lose-win, a win-lose, I don't know. If you can recognize it, it's kind of nice. But it's kind of like a trick you have to remember. So, and it's not the beginning of the problem. Sometimes the beginning of the problem will have a negative, but then you'll divide by a negative and it will fix itself. So you can't see it in the beginning of the problem, you can only see it right here. If an absolute value equals a negative, that's a problem. That means no solution. Okay, for this one, I'm going to let you guys kind of work through it. And then we're going to check we're going to check each step as we go, okay? So negative 10 minus the absolute value of negative 2x plus 7 equals negative 21. This problem has a lot of negatives, and this problem is not a no solution. This problem you can actually solve, okay? Even though it has a bunch of negatives in it. Okay. So we're going to do this one step at a time. The first step is to find something to add or subtract to the other side. And there is something, and I want you to take a moment and figure it out, okay? So we're going to take this problem. We're going to find the number that we have to add or subtract to the other side. And I'm going to give you guys a moment to find it. Add the number to the other side. Anyone want to say what they added? 10. Mm-hmm. Okay, next we have to figure out if we're gonna, and there is a step here, what to multiply or divide to the other side. There's something you could multiply or divide to the other side. You just got to see if you can figure out what it is. Anyone want to say what they did? What are we getting rid of? The what? Yeah, the negative in the front. So you can think of this as like a -1 in the front. And you can multiply or divide to get rid of it. It just kind of depends on your preference. So what would you guys rather do? multiply. So we could multiply the left side by a -1 and multiply the right side by a -1, and that would get rid of it. Or you could divide. Both of those things would do the same. Okay, so -2x plus 7 and an absolute value equals 11. Okay. So we have an absolute value equals a distance of positive 11. The number inside the absolute value equals a distance of positive 11. So at this point, you guys can write the two equations. Go ahead and take a moment, write the two equations. So what do we have for our two equations? Okay. And then what else do we have? So equals positive 11 equals negative 11. Okay. And then I want you to go ahead and solve both of those equations so you can tell me what the x equals. Lexi, your phone has not stopped buzzing. Isn't this distracting? No. Oh, it's not on Do Not Disturb. I mean, it's distracting me. How does this not distract you? Like, it's buzz? Is buzzing? It's buzzing right now. Is buzzing right now. This is buzzing. Is buzzing. It's buzzing. It's buzzing. It's buzzing. It's buzzing. Nope, it's buzzing. It's buzzing. It's buzzing. No, it's still buzzing. It stopped. It stopped. Okay. It's been buzzing the whole time I've been doing, like. It's wild. That's wild. You're very popular. I'm impressed. That one person is they think you're cool. You're very popular with them. Oh, it's buzzing again. Yep. It's wild. All right. So what do we do? Okay. So we got negative 2x equals 11 minus 7, 4. 11 negatives and 7 negatives. Negative 18. Okay. And then what do we have to do? Okay. So what are the two answers? You're very close. Your signs are a little off. So, so positive 9 over here because you had two negatives. And then positive 4 divided by negative 2 is negative 2. Okay. So to practice this concept, I have some extra credit today. So, so I'm going to hand this out. we are going to do the odds. The evens are extra credit. Okay? We're doing the odds. The evens are extra credit. So when you look at the sheet, the odds are the left column. We are doing the left column. The right column is extra credit. We're doing the left column. The right column is extra credit. Okay? Front and back. So the front side of the page is a little bit easier. The problems get more difficult on the back side of the page. The odds are regular credit. The evens are extra credit. Yes? Okay. So first, let's go ahead and write down which ones we're doing. So we're going to do the odds, which means we're doing all these.
Are we taking any more notes?
Nope. Nope. Okay. Now, remember to look out for the ones where you have an absolute value equals a negative, because there are multiple problems that have that situation on the worksheet. Okay, so watch out for those ones. Okay, so the first problem goes back to the easier ones, so we're going to take our notes, we're going to go back. Okay. How do we do number 1? We say n has a distance of 10 from 0. So what numbers have a distance of 10 from 0? 10 and negative 10. Okay. Number 3 is kind of similar to the second example we did. So we say, like, okay, what's inside has a distance of 8. So we're going to think of it like you go left 8, you go right 8. So we're going to write our two situations. We're going to say, okay, it's like you went to the left 17 for one situation. It's like you went to the right 17 for the other one. And we can solve it. Okay. All right, from here, I'm going to let you guys go ahead and work in your groups, okay? And while you do that, I'm going to come around and pick up assignments. Yep, you keep going, you get them solved.
stick